In this lecture, we will discuss about the RMSProp optimization algorithms. So before going to discuss about this one more optimization algorithm, in earlier classes, we discussed about the normal stochastic gradient descent algorithm as well as Adagrad algorithm. So in the first class, we discussed about the stochastic gradient descent algorithm. In this one, if I'm coming to this one, this is the updated equation. That here is a new weights or new biases are getting updated by old weights or old biases minus alpha into, it is a gradient at that time. Okay. So this is alpha is fixed. Alpha is, if I'm taking slower rate for better convergence, otherwise we have to take the higher rate for speed up. Okay. The disadvantage of this stochastic gradient descent method is that this alpha is common for all weights and biases. So it is also called as hyperparameter. So earlier, before initiating the program, we are fixing this value. So this somewhat disadvantage in SGD. So this can be overcome by the proposed method, that is Adagrad optimization, adaptive gradient optimization algorithm. Here, instead of fixed learning rate, they have taken, it's a variable learning rate. Variable learning rate in the sense, for each weight, let us take 1, there is a one parameter, that is learning rate. Example, W1 to another weight, there is a different parameter. Example, alpha 1 equal to maybe 0.2, this will become 0.01, like this. Different learning rates will be assigned to the weights as well as biases, whichever the feature is more important. So we have to implement this learning rate to trace correctly. Okay. So these are depend on the number of features. That's why this Adagrad algorithm is used for when the data is sparse. Okay, if the data is sparse, then or sparsity, then we will implement the Adagrad. In sparse, we have a lot of feature values are 0, so we have to ignore those feature 0 values, and we have to concentrate more important features. In those cases, learning rates are, we need to keep different values. So this is the formula for this one. This is here we have accumulation of gradients. How we have implementing this variable learning rate, in the sense, we are accumulating of gradients. This is the old gradient value and this is the current gradient value. So after getting the GT, we are substituting over here this epsilon it is to avoid the 0 in the denominator. So therefore, this fixed learning rate become variable learning rate for different weights and biases. Now in this class, we will discuss about the RMSProp optimization algorithm. So here it is also an adaptive learning rate optimization algorithm, and especially improved for the it is used for gradient descent algorithm, gradient based optimization methods. And the advantage of the RMSProp is over the Adagrad is the disadvantage of Adagrad algorithm is the aggressive learning. Okay, due to the aggressive learning, so sometimes it will be very fast, sometimes it will be very slow. That's a disadvantage of the Adagrad algorithm. So this can be overcome by here RMSProp. Instead of taking like this, so we are taking squared gradient moving average. Okay, we are computing the gradients in the form of squared gradient moving average. So this one is simply, if I am going this one, it helps overcome the limitations of standard gradient descent by addressing the issue of vanishing and exploding gradients. Example that I said in the just earlier, with the aggressive learning will leads to the either convergence or divergence. So therefore, we need to reach slowly towards the convergence, and we have a control over the gradient also. Therefore, RMSProp will be useful very much in such type of cases. And remaining is almost all same like a Adagrad algorithm. Here gamma is we are usually take 0.9. So this 0.9 means automatically the new gradient will have a very smaller weightage as compared to the earlier gradients. By the way, we are making a control over these gradients. And here GT is the current gradient, and this one is the previous gradient. Gamma is the one parameter to the range in between the zeros and ones. Okay. And update parameter is same like earlier one. So theta t minus eta into E of g square of t plus epsilon. Here epsilon also, so you have to avoid the 0 in the denominator. And now come to the one example problem statement. We want to minimize the one function they have given. They are asking to minimize this function by using RMSProp. RMSProp means the root mean square propagation. Okay. And remember that first we have to minimization. First we need to take the derivation of the function. And obviously, after taking the derivation, it becomes 2x plus 3. And initial parameters I have taken x naught equal to 2, and learning rate equal to 0.1, and gamma equal to 0.9, and epsilon equal to 10 to the power of minus 8. So then starting gradient I am taking equal to 0. So first x naught equal to 2. Substitute this x naught here in place of 2 into 2 plus 3, and it is a 7, the gradient is. And if I am substituting over here, that I said already gamma, I have taken 0.9 and multiplied with the initial gradient is 0, and 0.1 plus 7 square, then answer become 4.9. Now, after getting this one, we are substituting in the updated x old is already said, that is a 2, and eta is a 0.1, and this one become 4.9 into 10 to the power minus 8 plus 10 to the power minus 8 into g naught. G naught is the your gradient. Okay, after substituting this one, the new updated value is 1.6836. Now in the iteration number 2, that is step number 2, x1 value now become 1.6836. I am substituting over here. I am getting the 6.3672. Same procedure I am repeating. So after repeating this one, 8.464, then substituting in the new x value, then you are getting 1.464y. And this 1.464y I am taking in the third step, that is the third iteration. Same procedure we are continuing, and finally we are getting is 1.2865. So like this process continue to minimize the value. Okay, x value where it can minimize. So let us come over here. Where it can minimize means it is simply convex. Okay, so there itself we have a minimized value. So slowly the x value will go like this, because we have a learning rate. It depends on this past gradients. Okay, sometimes it is very aggressive, sometimes it is very small. But when we are taking gamma value is 0.9, then automatically whatever the aggressive, it can be reduced, because 1 minus 0.1 means 0.1 into your current GT. Okay, so this will reduce the aggressiveness of the current our GT. Okay, so this will slowly go towards the minimum value, that is we can call it here it is, we can call it as a global minima, local minima, because we have only one thing, one value. And so this is the process of RMSProp. So I said already what is the advantage of the RMSProp is that it's aggressiveness. It will reduce the aggressiveness which is facing in case of anti-grad algorithm. The remaining is same, because here the fixed learning rate become indirectly variable learning rate for each weight and biases. Okay, when loss become, that is how you will start in your neural networks. Simply if your loss it is not equal to 0, then you have to go for the back propagation. Okay, back propagation mechanism. In those back propagation, you are differentiating any one of the weight. It is, for example, dou L by dou W over there. So this is the differentiation. Okay, this is the whatever the equation we are getting, we are making differentiated, and after differentiating, we are substituting the values, and there itself we are finding the moving average gradient algorithms. Okay, so this is the way to optimize our weights and biases in artificial neural network, that is either single layer neural network or multi. Especially these optimization algorithms are used in multi-layer neural networks. Okay, thank you. If you like the video, please click on the like button.